Hi everyone, this is Olushal Audio. You're welcome to my presentation about PowerShell Pester V5 tests and the integration of this test into an Azure DevOps CI/CD process. So we start by taking a look at the code base, which is in Visual Studio Code. So I have a bunch of tests that I've written here, all conforming to the V5 standards, and we're going to run through these files very quickly and try to run all of the tests. So let's start with this one that I've called pester00.sample.tests.ps1, and let's just make this wider. Yes. So if you understand what a pester test looks like, you should be familiar with this. Essentially, what you want to do with a pester test is to test your logic, test your code, and make sure that the tests run successfully. So within a pester test, you have what you call a describe section. A describe section, and within that describe section, you also have, or you can have one or more context sections. In fact, should I say zero or more, because it's possible for you not to have a context section within your describe section and then go straight to have an each section. But an each section really is like a unit measure of a test. So when the engine is running, it considers everything within this each section as one test that must either pass or fail completely, or must either pass completely or it fails. So those are the three major sections within your pester test: a describe section, a context, zero or more context sections, and it sections. And it is the smallest unit that measures whether a test has passed or failed. You can get more information from the pester documentation here. So I think the one, so pester.dev docs usages tags, and I think the one that will interest us the most is this bit here, data-driven tests. So we can have a look at the workflow, how the logic runs within a typical pester test. So let's scroll over to, yes, the execution. Yeah, the execution phases. Now in Pester version 5, we have a new way of doing things called discovery and run. So in the old version, everything ran in just one flow, all the way from here to here. But in V5, we have what we call a discovery phase. So discovery phase runs, first of all, runs in your describe, runs in your context, and runs in any other one that is outside of the it, before all, before each, and after each, and after all. And what it tries to do on a discovery is to find out how many tests are we actually going to run. So it's just a way of like enumerating how many tests will eventually be run. So once this discovery phase is done, it will then come over here to the before all and run the code, whatever code you have within your before all the tests begin to run. And then it will run it before each of these it tests, and then run an after each of these it tests, and then run an after all when all your tests within that context have been completed. So that's the new method. You have a discovery phase and you have a run phase, and all these sections here, you can put some code within it or logic that would run, but you need to make a decision what sort of logic you'll be putting into these sort of places. If you want something to run before any of the tests run, then you're going to put your logic into before all. If you want something to run after all the tests have run, you're going to put your logic in after all. If you want your logic to run before each test is executed, then you're going to put it here. If you want your logic to run after each of the tests is executed, you're going to put it in after each. So that's the way the execution goes. You have a discovery phase and then you have a run phase. And within the discovery phase, it runs through all the tests to enumerate how many tests are going to be run, and what sort of conditions and filters that are going to be imposed on those tests. And we'll see more of this later on. So make a note of this: pester.dev docs usage data-driven test. In fact, let me just copy and paste this into the README of our application. Yeah, and just keep that here. Okay, so now let's go back. This will then begin to make sense. So this logic here before discovery, I've tried to annotate these right whole statements with enough information that will tell you what is actually going on. So this part runs, says before discovery. This is to set stuff up that we may need to inject into the describe. So this, whatever you put here, runs before it gets in here as part of the discovery. Now, when it gets into the discovery, you also have another before discovery section that you can put in here that is going to run immediately comes into the describe section before it gets into all these areas. So this before discovery runs before you enter into the describe segment here, and this runs immediately after you get into the describe segment before any other thing happens. And there is a significance to that. I'll show you, I think somewhere, yes, this one. So you can see there's a before discovery here where we went to look for the number of scripts that end with the extension PS1. And we write the number of scripts we discovered. And what we then do is to pass those scripts as an array into the describe. So what we're telling this describe to do is that for each of these files that we discovered, run this describe, this entire describe logic. So this describe, if we discover 10 files here, this describe is going to run 10 times. One for each of the files that we discovered in this query. So that's why this is relevant. This is relevant. So this is going to run before we get in here. And then there's another before discovery that is running based on one script. Because the moment you enter into this describe, it is only one script that is known to this entire segment. So that one script, you can see we're grabbing the full name here. We're grabbing this actual script name here. And then we're, doing quite a number of other things, to get like the parameter count and all the rest. So you see the relevance now of having a before discovery before you actually enter into your describe. And then you have another before discovery, but is operating within the framework of this describe. So everything here can only see just one file at a time. That's why you have a for each. So this is like a for each loop that runs this describe mechanism the same number of times as the same number of files that we discovered here. So hope that is understood. So describe, so this runs before any other thing runs within here, and this is going to get written out during the discovery phase. Now during the discovery phase, if you look at that, if you remember what we had in that chart, this entire lot is not going to run. Let's have a look at the chart again. You see discovery phase, before discovery runs, we get into the describe, but you see all the befores and the afters, but before each after all, none of them is going to run as part of the discovery phase. And let's get back. Then you have a context that sits within a describe. So within this context, you also have a before discovery, before any other thing runs. And then this is going to run. Then you also have the eat. Now the eat will not run because these are the actual tests. So the tests are not really going to run. And then it's going to print this out. Then going to go to the next context. And after this context is completed, it's going to now say we're leaving this describe. And then we'll say we're done with discovery, but no tests have been run yet. So it's going to go all the way through the before discovery statement, and yet it will not run any test. So the way to verify this is to run our test in debug mode. Visual Studio Code has a very nice facility here where you can just click on this, run test, debug test. So let's run the test, this one. Let's drag this up. Now you can see this, starting discovery in one files. You can see it printed it out. Before discovery, this is to set stuff up that we may need to inject into the describe. Before discovery, inside the describe. You see, before discovery, inside the describe. We are finding tests in this describe. Then it goes on to print this out. So everything in here is going to run first before anything else runs within the describe. We are finding tests in this describe. Now you can see this did not get printed, this did not get printed, this did not get printed, this did not get printed. It goes straight into the context. And it says before discovery inside context 1. Can you see? And then it goes on to print. We are finding tests in this context. Now this is not going to run. This is not going to run because we are not running the test yet. We're still in discovery mode. And then it goes to we are leaving context 1. Same thing with context 2. Before discovery, inside context 2, we are finding tests in this context. We're leaving context 2. And over here, when it comes out of the last context, we're leaving this describe. It's going to print this out. And we are done with discovery, but no tests have been run yet. So we've done all this entire discovery phase. And what this discovery phase will do for you is to then tell you the number of tests it found. So it found 4 tests. And the next thing it's going to do is start running the test. Now, before it starts running the test, you're going to have a before all. The before all the tests will run, which is here. And then before each test, this is going to run once before this first test begins to run. So before each test, I am running test 1 and after each test. Before each test, I am running test 2 after each test. Before each test, I'm running test 3 after each test. Before each test, I'm running test 4 after each test. And then you're going to have your after all tests run. And once this is done, after all tests, you come to the end of the story. Test passed, 4, job done. So you can see the execution flow now. The discovery is going to run through everything apart from the eat and apart from the before alls and the before eaches and the after alls and the after eaches, and then come back to run any possible before all, before eaches, after eaches, and after alls as it runs the tests. So that's Pester version 5 for you in a nutshell. If you understand what I've shown you here, then you fully understand Pester version 5 upgrade. So let's look at a few tests here that I've put together to do something useful. So this first test is what we call a help quality test. Now, what is the role of an help quality test? Is to test each of your PowerShell files to see if it has these following annotations: synopsis, description, and example. And also it's going to test if it has parameter definitions as well for those PowerShell files that have parameters. So let's run through this very quickly. Before discovery, before anything happens, we want to first of all get all the scripts that are PowerShell. So number of files discovered is going to print this out in the diagnostics. So for each of the files discovered, it's going to run this describe section for each of the files discovered. Now it's going to get the script name, and now it's going to get the help. So what get help will do is to read that script and extract this section from the script, this section here, this section, this section. And what it's gonna do also, this bit here is counting the parameters involved, counting the parameters involved in that script. So the first context I put up here is to check for the basic help, which is, does he have a synopsis? Does he have a description? Does he have an example call? And then the second context here is for parameter definitions. Parameter definitions. So here it's like, okay, it's going to check through the parameters and see if there are parameters defined and if those parameters have a description. So that's the role of this context here. And it's going to run this for each of the PS1 files, PowerShell files, that it finds in the entire solution. And this is how it does it. It goes to the root of our PowerShell run and looks for every file that ends with PS1. And then it will run this describe for each of those files. So let's give it a go and see. Run tests. That came back very quickly. Total tests passed 50. So if we really want to see what has happened, let's run debug tests. So you can see here, let's go to the top. So what has happened? Number of files discovered for help quality test, 13. So let's be sure it's not telling us a lie. 0 to 9 is 10 files, 11 files, 12, 13. So it scanned this entire folder structure and found 13 PowerShell files. So it then will go through each of the 13 PowerShell files. You see, describing help quality tests. For it will put the file name here. Also, help quality test, put the file name, and then it will begin to run it. So should have a synopsis, should have a description, should have an example. So this one passed. Create app authentication. The next one, the parameter definition. So it has two parameters, resource group and function app name. And then the next one, toggle app authentication, has a synopsis, description, example, and parameter descriptions. 3 parameter descriptions. Then it goes on, runs through all the files. Let's have a look at this one. 00 sample test, PS1. It has a synopsis, has a description, has an example, but it didn't run any test for the parameter descriptions. Why? Let's have a look. Because it doesn't have any parameter, you see? So our logic takes care of files that don't have any parameter, and this is where the magic is done. So parameters is this. Then if help.parameters.parameter.count is not equal to 0, then set these parameters is equal to this. So this is where you have the array of parameters. And if this is not going to run, if it is an empty parameter array, is not going to run. So that's why this context did not show up for this file and this file and this file. So what this helps us to do is ensure that DevOps engineers, especially who have to write PowerShell code, PowerShell logic, and a lot of things in PowerShell, do not just slam code into the code base without giving any thought about a synopsis, a description, and an example, and the parameter definitions. And that is how to self-document your code. Because these days now, there's really no time for people to sit down and be documenting a code base. I mean, that's old school these days now. So we must have tools that ensure that you actually document your own code. And if you don't document your own code, we must have tools that will flag it up and enforce that practice. So this is good practice. You must have a synopsis, description, example, and parameter definitions within this section here. So let's look at another test. This one, we call it code quality test. Now, code quality test, as I call them, piggyback on the PS Analyzer framework, the script analyzer, PS Analyzer framework, where you run all sorts of tests, quality tests against PowerShell code. So same principle again. We grab all the files within the solution, and additionally we grab a PowerShell module. We have a PowerShell module here with a couple of functions in there, very simple functions. So we grab all the code into a collection. So we'll grab the module first and grab this one. So in this case, we're going to get 14 files, 13 PowerShell files and one module file. So we should get 14 for this one. Very simple again. It's going to run this describe for each of the each of the files that we discover, and get the script name. And then it's going to set up an array, a collection of rules that we really don't want to test. But there are several other rules that will be tested. Probably about 65 rules will be tested across each file. And then rules is equal to get script analyzer rule. So this is the bunch of rules. And then we're going to pass in the script name, the rules, and the rules we want to exclude rules into this context. In fact, they're already in this context, but then we're now going to pass them down into the it through this for each. Now when it gets here, so for each here, when it gets into the it, is going to now run the test for each of the rules that we passed in. For each of the rules, run this test. Run this test. So this, no, I got that wrong. It's going to pass all the rules. It's going to pass all the rules in here. And this is the script name. And these are the rules that are going to be excluded. So all the number of rules minus these ones are going to be tested against the script. And the result count should be 0. So that's the way it works. So let's have a run. Run tests. Now this takes a lot longer than the other tests because it's going to run 65. I think about 65 tests. Okay, 910. How many files did it discover for test? Let's have a look. 14. So 910 divided by 14 tells us the number of tests that it ran. 910 divided by 14. Yeah, 65 tests. So it ran 65 tests on each of those 14 files. Now the way to really appreciate that is to run this again in debug mode. Can you see? 65 tests. Now this is the first file it picked up. So you see it ran all these 65 tests, 65 of them across each file, you see? Across 14 files. Still running actually. Still running. And that's it. All passed. So the way to really appreciate this is, I have a bunch of write host statements here. So what I can do is to take this out of the rules to be excluded by just commenting it. So I'll just comment this out and then let's run it again. Let's do run tests this time. You see all the number of tests failing? Why? Because it found write host statements in the PowerShell files and it doesn't want them. So 6 out of 6 tests failed because they had right host statements in them. So if we take this exclusion out and run it again, run test, all passed. 910 passed. Another thing we can do is let's add a space here, a white space. Now one of the tests also that it runs through is what you call avoid white space, like a redundant white space, a trailing white space. That's this test, you can see. So it's going to run through your code and make sure that you didn't include any redundant white space. So let's run the test now. So it's running the test. We should get an error. You see, expected 0 but got 1. And what was the rule? It was testing avoid trailing white space. So let's go back and remove the trailing white space and run it again. Just run it again. And there we are, passed. So this is a very nice tool, very nice tool. I love this. I actually love this, and I use this test to enforce code quality in our DevOps pipelines at work. So let's move on to another kind of test, different from help quality and code quality test, like unit tests, for instance. And this will have a lot more focus on the it sections than the describe and the context. So the first thing we do is to import the module, because we're going to be running some functions within the module. And now we're going to be testing this function, get something. That it should have a parameter called thing to get of type string. The default value should be something, and it shouldn't be mandatory. So let's have a look. Get something. So get something, can you see it? Not mandatory. The default value is something and is of a type string. So let's have a look. So you see, it has a parameter type string, it passed. Default value is something, mandatory. So let's change this to something 1 and run the test again. You see, it failed. It said the default value to be something 1, but the default value get to have a parameter thing to get the default value to be something 1, but the default value was something, so it failed. So let's take the 1 out and run it again, and it passed. And then over here, when parameter thing to get is not used, it should return I got something, and it should be a string. So let's run that in debug mode. You see, it's not used. It should return I got something, and it should be a string. And when parameter thing to get is used, it should return I got followed by the parameter value that was passed into it, and it should be a string. So you see that works very well. So next thing, this is not too different to be honest, but we just added I just added a mock here. So we're mocking this function here, new thing, and we're mocking it with fake thing, fake thing. So new thing should be fake thing. So if you call new thing, we should get fake thing, because we're mocking it with this parameter. Then should return assert that it was called. So new thing, if you mocked it here and then you called new thing, so should invoke new thing times 1. That's 1 time. So let's run this. Then it works fine. Debug test. So you can see the extra logic that went into creating the mock behind the hood. So let's do something slightly more interesting. Now we want to add two numbers. So we have an add numbers function here. So if we don't supply any number one parameter, it defaults to 2, and this also defaults to 2, and they're not mandatory parameters, and it will return the sum of those two numbers, So let's have a look here. So here we're testing the actual function itself, that it should have a parameter called number one, type int, default value 2, not mandatory. Same thing with the second parameter as well. So all the tests, they pass. So this one's passed because we had a look at the function and we saw what the function looked like. Now we have two contexts, in fact 3 contexts actually within this describe. The first context is that when no parameters are used, what should happen if we just call add numbers. So if you go to add numbers, when no parameters are used, your number one will be 2, your number 2 will be 2, and the answer is going to be 4. So let's come over here, add numbers. So when no parameters are used, add numbers should be 4, and also it should return an integer. So let's have a look. Let's run in debug mode. Yeah, can you see context? When no parameters are used, should return 4, should return an integer, passed. When one parameter is used, so let's say we used, or when one parameter is used, so let's say we used 4, for instance. 4 plus whatever the default is, which is 2, which we know to be 2, should give us 6. So you see 4 plus 2, 6, and 4 plus 2 return an integer. When both parameters are used, you can see that we set them up here in the before all. So this runs before the tests begin to run. We put this here because of the discovery process. So it can pass the number one to the outer section of this it. But the before all is what actually sets the variables within the it. So you need to pay attention to that distinction, before discovery and before all. So the before discovery here is what's going to set this number one here, but the before all here is what's going to set this number one here. So that's why the logic is repeated across before discovery and before all. Same thing here, before discovery, before all. You can see it's the same logic, because it's going to set what we have here, the before discovery, and the before all is going to set what we have inside the test. So you need to be very careful about that. So 14 plus 4 should give us 18, which you can see here, and it return an integer. Same principle with subtract numbers. The only difference between add and subtract are just the signs, to be honest. So we can actually go past that. Then I had what I call acceptance tests, which like I'm pumping a whole bunch of values into the same test and see, just testing out, how you can, test a lot of things in a loop with using a pester test. So you can see this context here. Before discovery, what I did was to set up an array where you're supplying parameters. So I just, did some little simulation here. So answer is equal to input 1 plus input 2. So I set up an array, number 1, number 2, and the answer, the expected answer. So this will run as part of the before discovery. When the tests are running, this is what's going to happen. This first test is only going to run once, because what I have done is to just pass a number. So just pass a number and just carried out the operation once, should be this, and that's all. These other test is going to run 100 times. Should run about 100 times, because I have 100 elements in this array, 100 times. And for each of them, you see, so I'm passing just the array here, which is very useful. And for each of these array is now going to unpack the number 1, number 2, and tell us that the answer of adding number 1 and number 2 should be equal to expected, which we already calculated here. When one parameter is used, now I'm going to just put just one parameter down and input 2, really is going to be, like 0. And then this is the expected answer. So once you pass this, number 1 is equal to 1, expected is 3, because the default of the parameter is 2, and this one too, number 1 parameter. So answer is equal to input 1 plus 2. And this is going to run 100 times as well, because we're passing the entire array into this. I'm saying for each of the elements in this array, run this test. So it's going to run 100 times. Let's have a look. You'll find this more interesting. You can see it's scrolling across now. 100 tests and another 100. And we're done. 202 tests. So 101 tests here and 101 tests here, making 202 tests. Let's have a look at the first few numbers. See, number 1 should return 3 because the default of the other parameter is 2. Number 3 should return 5 because the default of the other parameter is 2. If you come over here to this one, 1 plus 2 is 3. That's simple enough. 3 plus 36, 39. Simple enough. 5 plus 37, 42. Simple enough. So our tests are passing. So same thing with subtract numbers. I just flipped the sign. That was all really. Then add and subtract. Slightly more interesting. Input 1 plus input 2 gives us answer 1. So these are simulations. Input 3 plus input 4 gives us answer 2. These are also simulations. Then final answer will be answer 1 minus answer 2. And then I put everything into the array here. And this is going to run 100 times. Yeah, I believe. Yeah, it should be 100 times. So within the eat here, remember I said that whatever you have in the eat makes up one test. But within that one test, we are doing 3 things. The first thing we're doing is adding number 1 to number 2 to get answer 1. So the result of this operation, we're comparing it with answer 1 that we passed into the, let me just expand this. Yeah, answer 1 that we passed as part of the array. Same thing with answer 2. And then it's now going to carry out a subtract operation between answer 1 and answer 2 to get final answer, which is what we passed in here. And you see, final answer is answer 1 minus answer 2. So let's have a spin. Came back quite quickly in 1.38 seconds, but let's run the debug so we can see what it actually did. So you see, the cool thing about this before discovery is that I've put everything I wanted to use inside this collection here and passed this collection to the eat and said, for each member, for each element of this collection, run this test. So you see, the first element, he was able to unpack number 1 as 9, number 2 as 36, number 3 as 23, number 4 as 2. 9 plus 36, 45, minus 45 gives us 20. And this 20 is the final answer here, which is now comparing with this third operation. So this and this and this, all 3 must pass for this test to be flagged as correct. And it ran this 100 times. Test passed 100. So you see, we've come to, well, the end of all the tests here. Another file we should, have a look at is the actual Pester PS file that we are going to run within the pipeline. So what I will do is it will check if we have Pester installed on the build machine, on the build server. And then the next thing is it will print out the Pester version. And if we set up a publish parameter, it's going to create the folder where we want to drop our results into. And then it's going to fetch the tests that it should actually run. So it's going to look for anything that ends with tests.ps1. So these files. So it's going to look for all these files here. It's going to get them, 10 of them, put them into these parameters, whack them into this container, and whack them into this configuration object. Interesting. Output, we're going to set the verbosity to whatever verbosity we pass in. Filter, we're going to set the filter, the tag, to only run tests that have this supplied tag. That was something I forgot to show you. Now you look at this. I have a tag here called don't run. This one, I have a tag here called quality. So 2 quality tests, 1 don't run test, 2 quality tests. This one, they're all unit. So I tag them as unit. Then this one, I tag them as acceptance. This one's I tag them as acceptance, and this one's I tag them as acceptance. So we have 1 don't run test, 2 quality tests, 1, 2, 3, 4 unit tests, and 3 acceptance tests. Now, if you remember, each time we ran this, everything ran, all the tests ran, which is no big deal. But when you come into the Pester here, whatever tag you supply and you set here determines which of these tests that were all discovered will run. And we'll see that in the pipeline when we get into Azure DevOps. So that's the role of the tag. Now let's look at the other files. Job templates. So this is where the flow comes through. So I actually have 3 calls from my Azure pipelines to this same file. So you can see the difference is the tag. So I tag this quality, tag this unit, tag this acceptance, and there's no don't run tag. And we'll see how that works out. So, and also the name of the files are different. I just give them different names because these files are going to be stored in Azure DevOps, and you'll be able to see an analysis of your results. So that's a good part of this. And let's look at the Pester test. This is what you call a YAML template. So it's going to call this YAML 3 times, and it's going to pass these parameters through. And this YAML has 2 tasks within it. The first task is to call pester.ps1, and which would actually run the tests and store the results in this file. Where's the file? We're supposed to have supply. Yeah, test result file. Yeah, to store it in this file, in this folder, and this will come along, pick up the file, and publish it into Azure DevOps. Very simple. So I've given you a full rundown of all the files I have in here. So let's begin our journey to move this into Azure DevOps pipeline. So the first thing I want to do is to do a git add. And then git commit. Initial commit. I'm sure that will look familiar. Then change the branching system. I love using master. I don't like using main, so I always change my stuff to master. And the next thing I want to do is to set up the remote. Git remote add origin, git add GitHub colon. Yeah, so I want to load this up into my GitHub account. Shall I add YouTube Pester demo.git. So let's go through that again. Git remote add origin, git add GitHub, shall I do /YouTube Pester demo.git. Yeah, that looks right. So the next thing we want to do is to create the repo. So let's go to GitHub, your repositories. Oh, I should have used that plus button there. new repository, YouTube hyphen Pester demo, create repo. So the last thing we're going to do is to push. So we're going to push it up to the repo now. Git push -u origin master. Git push -u origin master. Make sure you have the correct. Could not read from. All right, let's see. Git remote add origin. Git at GitHub. YouTube pester demo. Git. Oh, could not resolve. Oh, I found it. Git at github.com. That was an error there. Okay, let's see. Yeah, I need to do some slick. Can I remove this? Remove. The one that didn't have the com. Oh, remote. Remove the name. Oh, okay. Okay, this is what we're going to do. There obviously was a typo there, so what I'm going to do is I'm going to close this rather than look for, just close the, so I'm just going to close the folder, and what I'll just quickly do is drop this here. Okay, so YouTube, that's where all our files are. So I'm just going to copy and just back it up somewhere. Back up and take this down. Move it to the bin and then create another one. YouTube Pester demo. Then take the files, copy, and drop it into YouTube Pester demo. Drop it into YouTube Pester demo and come over to the code, read them in again. Awesome. So let's run PowerShell cd and let me just run okay, and let me just copy all these across. because of our time. All the things I typed in earlier. And then we'll do a push. We already have the repo created up there. And boom, we're done. So it's gone all the way up to GitHub now. YouTube Pester demo. You see all checked in. Resources, test on the master branch. So the next thing we want to do is come over here into Azure DevOps. Into Azure DevOps and create a pipeline. So new pipeline, GitHub, and that's our repo there. So it's going to try to install some stuff. Approve and install. Yeah, the Azure pipeline apps. Okay, so it's done. Existing Azure pipeline YAML files. So we pick our Azure pipelines file, continue, and then we run it. Particularly, we're going to see the operation of the tags. That'll be a very interesting one. So let me rename this pipeline. Yeah, take out my name. So what's going on in this pipeline? 3 tests. Remember, there were 3 jobs on that pipeline I showed you. Code quality test, unit test, and acceptance test. If you remember, let's say. Let's drag this down. So you can see code quality test, unit test, and acceptance test. So those are the 3 things running. Code quality test, unit test, and acceptance test. There's something very interesting I need to show you on this test. Now, if you come along here, you'll see that, you know, the file where I wrote "don't run" as a tag, it actually opened the file, discovered the tests in the file. So you see, these are the discovery diagnostics. But when it came to running the tests, it says filter tag set to quality. So for quality, it selected 960 tests as part of our quality tests. And you can see it's running through all the files now. These are the help quality tests. It ran first across these files, and then it ran the, sorry about that, then it ran the code quality tests. You see, running through all the code quality tests. 65 rules for each of those 14 files, giving you 910 tests. And there were 50 help tests, 960 tests. But you see that these tests that were associated with these ones, this particular file, none of them got ran because this tag here is quality. So we're saying that we only want to run tests that have the tag set to quality, even though discovery ran through all the files. But after the discovery, we're only running quality tagged files. Same thing with this one. After the discovery, we're only running unit test tagged files. You see, filter tag set to unit, and only 25 tests met that criteria. Get something unit test, new thing unit test, add numbers unit test, subtract numbers unit test, and that's it. Now if you come to the last one, acceptance test, same thing. It ran through every file we had in the file system, and it came up with 1,493 tests to run because of this tag set to acceptance. Oh, sorry, 504 rather, because of this tag set to acceptance. 504. And you see that these 504 tests did not include the tests that were actually inside this one, which had a tag of don't run. So you see, our 100 numbers as simulation running again for this test. Now, another cool feature I want to show you again is that after these tests were completed, it did a publish. And if you click on this link here, this published test run link here, where does it take you? To the Run Explorer to show you the result. 960 tests. You can see each of the tests here. See? You can see it. If you double click on them, that's a test. Which is very cool. So 960. And if you come over here, unit tests, we should get something smaller. Publish unit test. If you click on this, see we had 25 tests running there, just 25. And if you go back and click on the acceptance test, you should have quite a lot as well because of our simulations. (504) tests, you can see, and this will be stored, archived into your Azure DevOps. See, it runs. So if you look at the time, 225, these three ran just about next to each other. These are previous runs I've been playing with before I started the broadcast. So you see, you have a record of your tests, how they performed, whether they passed or failed, which is very cool, very nice. So let's go back. Yeah, we're pretty much almost done with this presentation. I just want to show you, just one or two things. If we go back into GitHub, go into the settings here, we can create what we call a branch policy, add rule, and give the rule a name, call it master. So require a pull request before merging, and require approvals, require status checks to pass before merging, require branches to be up to date before merging, and include administrators. I won't do this because I'll lock myself out. I'll need someone to approve my PR, but ideally someone else should be approving your PR. So you should always click this, include administrators, and then you save this. So what we have done is we have created a branch protection rule that prevents anyone from checking stuff directly into master. And this is where it's useful. So imagine now we've prevented people from checking stuff into master. So imagine a rogue or a crazy developer turns up and does a git checkout -b, let's say stupid branch by crazy DevOps. So he creates a stupid branch by crazy DevOps. Then he comes in here. Let's copy this file. So let's say he comes in here and creates his own file. We'll call it copy. Let's rename it. Let's call it stupid. And then it turns up here. He provided no description. And then he saved it. And then what else did he do? Put in some trailing white spaces carelessly, saves it. Now, if he didn't really care or bother to run these tests locally, so let's say this one, for instance, run it locally. Oh, okay, that's a sample test. No, that's not the one I was looking for. The help quality tests. Now this should fail because he did not provide a description for his new routine. Yeah, there's no description. And then the code quality test too should fail because he included some crazy white spaces in his new PowerShell routine. So you see, that enforces compliance. But let's imagine that he was really a crazy person and he still ignored all this and decided that, okay, I'm going to check this in. So let's call this crazy check-in. So he decides to check this in. And then he decides to push it. So what happens? Let's go to Google Chrome and let's see what's happening here. So it's aware that a new branch, stupid branch by Crazy DevOps. And then, well, let's go into the pipeline. You can see immediately is running individual CI for this stupid branch by Crazy DevOps. And let's see what happens. Code quality tests. One of them should fail. In fact, the code quality should fail, help quality should fail, which is really very cool. You can see it failed, and it tells us why it failed. Expected a value, but got nothing in the description. So that failed. And these also failed because of trailing white. Yeah. It failed because of trailing white space. You see? Avoid trailing white space. So wait for all these tests to complete and then we read the report. So the acceptance test passed, obviously, because it didn't have any logic under the acceptance test. The unit test also passed because we didn't impact any of those. But then the quality test should fail. You see, publish pester test failed. So if we now go into the report, yeah, passed and failed. You see, failed. This failed, and this also failed. Yeah. So run summary. See, passed and failed. There was quite a minute failed. 2 tests failed, but 1028 tests passed. So this is really very cool. So it can't get anywhere because even if you try to create a pull request, someone has to approve the pull request. Someone has to approve the pull request. So it's not even going to work. It's not going to work at all. So this is a way to enforce code quality. So once you set GitHub up that way, it means that no one will be able to check any rogue code that fails your test because someone else has to review the code and PR it. And if he forged the tests just so that his crap PowerShell routine can run, whoever is doing the PR is going to find it and detect it. So this is a way to enforce code quality within PowerShell routines. And a massive shout out. So let's complete this job before we go so we can leave the code in a very good state. Let's go over to, yeah, the one we call stupid, and let's look for the white spaces. Yeah, so we've taken off the white spaces. In fact, let's just do a Control-Z. So we've restored everything back to shape, and let's check it back in. So let's call it good good checking. So that goes straight up to the branch, and then we push, and our CI/CD kicks in. Pipelines. Yeah. So that's pipeline. So you see it's running. Good checking. So I don't expect anything to fail now. So, and because we're hopeful that it's not going to fail, we can as well create a pull request. Ooh, what happened there? Is my internet down? No. Oh, okay. So I've created a pull request, and you should find two things running here. Okay, just one. YouTube Pester demo. Okay. So what happens when you create a pull request is that these tests are going to run all over again. They're going to run all over again, and they're never going to allow merging to happen if any of these tests fail. So yeah, I need two things had to run. A CI had to be running, and also a PR build also had to be running. So this PR build must complete successfully before we can get to go ahead here. See, some checks haven't been completed. One queued, one in progress, two successful checks. So still running. Yeah, let's check this one's out. Yeah. Acceptance tests. Yeah, that should be done now. That should be done. And code quality should be almost done as well. Yeah, that's done as well. So if we go here, all checks have passed. So it needs an approver. Now I can approve my own PR because I'm the only one on the broadcast. So if I said you cannot approve your own PR, then there'll be no one to approve the PR. So I can actually go ahead and do the merge. So I can go ahead and do the merge. Let me just refresh this and be sure that we're okay. Yeah, so I can go ahead to do the merge and user administrator privileges to merge this pull request. Merge, and then delete the branch. So it's matched the code into master. So if we come over here, we only have a master branch now. So it's matched our changes into master. And the way we know that is, let's go into resources, PowerShell scripts, and that's the new file created by the crazy DevOps. And if we come in here, a CI build should be going on the master branch. Yeah, CI master. So that should be going on. And if you go back into the code over here, cd ... let's switch over to master, git checkout master, and if you do a git pull to pull the latest changes on the master, you see a new file, create app authentication stupid. So we'll come to the end of this broadcast. In a nutshell, we've been through quite a bunch of PowerShell Pester version 5 tests, and we've looked through the workflow, how a typical Pester v5 test will run through the discovery phase and the run phase, and we've also been able to put this into a pipeline, into an Azure DevOps pipeline, and we've been able to run that pipeline. We've been able to create a small process where DevOps engineers are forced to adhere to code quality standards as stipulated by the Pester version 5 test. So this is a real very good way of maintaining your PowerShell code base within your Azure DevOps estate. So hopefully, sometime very soon, I'll come with something else again about PowerShell. But I actually love PowerShell, and I love Pester version 5 test. Very nice. I always pick up any opportunity to write or amend Pester 5 tests, wherever I find them. Make sure that they're all running okay, and make sure that we're all forced to adhere to coding standards. And no surprise, really, I used to be a developer for 20 years before before I switched over into the world of DevOps. So that's the developer part of me still screaming. So bye for now, and hopefully I should come to you another time with some good stuff about Azure DevOps or PowerShell. So thanks for watching.